Hi folks, back today with another question. This isn't a kinematic question. This one is a classic ball being dropped question. So there's not much information in this one. You got to actually infer some information, go by what you know, do some logic. So, as usual, we'll highlight a few things as we go through. So, ball's dropped off a bridge. It takes 4 seconds to hit the water below. How high is the bridge, and how fast the ball going when it strikes the water? And all we have is 4 seconds. And we know how high the bridge is, and how fast the ball is going. So let's this one it's always good to really make sure you write your givens down. The other sections we can label diagrams, and we could do that here. Maybe we should do that. Let's do that. So there's the bridge, and we've got somebody dropping the ball to the water below. So what information do we know? Well, this is our starting height. We're going to make that 0. Actually, no, let's not do that. Let's do it the other way around. Let's make this our final height. Let's make our final height 0. And we want to know where we started, because really that's what's going on. We could do either way. Just remember that if this is 0, then that's going to give me a negative value. So, but we're going to solve the other way around, knowing that we end at 0. We don't know where we start. And we know the time is 4 seconds. And that's kind of all we know. So if you're looking at this question thinking, I don't have very much information. But remember, when this ball is dropped, what causes the acceleration? Right, gravity. So acceleration is equal to gravity, which is always negative 9.8 for kinematics, because we don't have a system that allows us to put the negatives in. So we need the negative to tell us the direction. And the other thing we're missing is the ball is dropped. So initially, the ball has a velocity of 0 meters per second. These two things, I'm going to highlight them. The acceleration and the initial velocity are both assumed. They're values that we needed to kind of remember, but they aren't given to you. So these are these trick ones that they don't give you much information. Remember gravity, remember initial velocity. So we need a formula. So I brought my formulas over with me. And these are the x version, but remember the y versions work the same. So the y versions for these two are the exact same thing. They just have y instead of x. So if I look at it, I'm looking for y naught. So this one has the x naught, so that would work. Do I have the initial velocity? Yes. Do I have the acceleration? Yes. I'm looking for that value, but the y version. But we don't know the final velocity. We're looking for, if we put the y versions of these, y equals y naught. We have this here value, we have this value, we have the time, and we have the acceleration. So that formula is out. That's out because we don't have doesn't have a value we're looking for. The last one. So let's pick this one. Remember, it's just a process of elimination. Which one works? Some people get really good at it and they don't need to look at to eliminate ones, but we, if you like, we look at our formula and we eliminate them. So again, we had to look at what we have. We're looking for y naught. So both these would work. This one requires final velocity, so we don't want that one. All right, so we pick this formula. We have our values. This is 0. This is our unknown. Our initial velocity is 0, so I'm going to cross that right out so I don't bring it with me. Plus 1/2. Gravity is negative 9.8. And the time is 4 squared. You should be able to put that all in your calculator. And if you do, you get 78.4. And then, of course, I want the y naught by itself, so I'm going to move the 78 over because these would move the negative to the side. And 78.4 meters is the initial height. So the bridge is 78.4 meters high. I also want to find the velocity. So I'm looking for the final velocity, how fast it's going when it hits the water. So I can use this equation now, because I do know the starting point. Or I could use, let's erase this stuff, get out of the way. Or I could use this formula. If you can use this one, use that one. It's probably easier, but you can do either one of them. V equals V naught plus AT. Remember this was 0. So the final velocity equals negative 9.8, because that's the acceleration of gravity. And the time is 4 seconds. Excuse me, I'm writing here a little bit fast. So I do the math. I get negative 39.2 meters per second. So I'll start at 78.4 meters. and it was going almost 40 meters a second downward when it struck the water. Of course, it'll slow down then. Remember, when the question asks you how fast we're going at the end, doesn't mean that it had no velocity, because it does have a velocity. So I'll just pull my statement out. I've been writing them ahead of time, so I have to wait for me to type them out. Bridge is 78.4 meters high, and the ball's traveling at negative 39.2 meters per second when it hits the water. Little box counting stuff up. All right. Again, we could have also used this formula here. Use the v squared formula if we didn't want to use this, the one above it. The trick of this one, though, if you do this one, is that you're going to take the square root of something. Remember, when you get to the point where it's a square root, it's going to be plus or minus an answer because we need a negative answer for this because the ball is going downward. All right. Same as always. If you have any questions, shoot me an email or drop in and see me, and hopefully this helped. Thanks.